over the public network, right? It will create a logical topology, right? It's will create a logical topology, and this logical topology is known as a overlay network as well as. So on the top of the existing network, right? On the top of this is my existing network, this is my underlay network, right? This is my existing network, this is my underlay. So underlay, right? On the underlay network, what happened by using the GRE, I'm going to create another overlay network. So like this, so after making a VPN, right? After making a logical connection between this guy to this guy, right? So my new topology will be now new topology will look like this. Router one, we can say that router number two, and look like this. So this is my logical topology that I'm going to create, or we can say that is my overlay network. So this guy has a, for example, if I'm going to make a configuration, so I'm just recapping yesterday things. Okay, so I say the interface tunnel one, IP address will be 101/24. Then after the tunnel source, I need to define, right? So from where I'm going to perform the encapsulation. So tunnel source will be 0/0, or we can put the IP address of this interface, right? And tunnel destination will be where the decapsulation will happen, right? So it should be 2.2.2.2. And now after that, I need to put the exit key, right? Same thing I need to do on the router number two side. On a router number two, I'm going to define this guy should be 1 or 2. So turn source on the router number two, I say that, hey, the encapsulation will be done by the 2.2.2.2.2, or decapsulation will be done on the this side, 1 right? So on a R1, this guy is going to represent, I need to perform the encapsulation. When the packet is coming to me, I need to encapsulate the packet, right? And the decapsulation will happen from this side, this guy. So this is my creating point. We can say that this guy is my creating point, right? And the, or we can say that here the GRE header will be added, right? And on this point, the GRE will be removed, right? So after making this configuration, what happened? I will get this topology. So we'll have a 12.1, not 101. That is my 192.168.101, and this guy will be 102, right? A tunnel interface IP address. So we can see that it's a direct connectivity is happening between the Delhi. So this is my Delhi side, and this one is the Bangalore, right? So between the Delhi to the Bangalore, we have a direct connectivity. This is my overlay network. And it's totally relying, this overlay network is totally relying on the underlay. What's the meaning of that? For example, if this link is not fine, right? For example, if this link has the, this link is no more, right? So what happened? This link also goes down. We can see that if underlay is not working fine, you cannot achieve the overlay. Never ever, never ever. You cannot achieve the overlay. So your complete overlay network is totally relying on the underlay. Your complete overlay network is totally relying on the underlay. So on the top of the existing network overlay, we are going to create the overlay network. So this is the very basic configuration that we did yesterday, right? This one. And this guy is going to make a site-to-site connectivity. This guy is going to make a site-to-site connectivity. So it's good. I'm not denying it's bad, right? GRE is good, right? At the time when the GRE has introduced, it was good. But the problem with the GRE, right? It only provides the site-to-site connectivity. This is the one of the biggest issues. The problem with the GRE, right? The GRE issue is the it only provides the site-to-site connectivity. So it means that if you have a look like this topology, take example, if you have a look like this topology, right? So let's change the color of this guy. Change symbol. I'll go for this guys, right? Router. Take example. So this is my ISP, right? So this is my service provider. This is my ISP network. And take example, if you have a look like this topology, we have a Delhi branch, right? We have a Patna, we have a Bangalore office, we have a Calcutta office, we have a Lucknow, we have a Goa, right? We have a multiple branch. Previously, what happened? If you see in this case, we just have a 2 branch office, right? One branch office, this guy is present in the Delhi location, and this guy is present in the Bangalore location. Just a 2 branch, right? But what happens if you have a multiple branch? Multiple, can you see that we have almost near around 6 to 7 branch, right? So branch 1, Delhi, Patna, Bangalore, Calcutta, Lucknow, and Goa. Different sites we have. So almost we have a 6 sites, right? And this is my service provider ISP that I'm not that's just going to provide the transport connectivity. That just going to provide the transport connectivity. Now take example, if I'm going to provide, right, if I'm going to make a VPN, if I'm going to make a logical connection, or if I'm going to make a overlay network between all the sites, how many VPN I need to create over there? How many GRE I'm going to enable? First of all, I'm going to make a GRE tunnel between this guy to this guy, Patna to Delhi, right? Like this. Then we need to create a Delhi to the Bangalore. Then we need to create the Delhi to the Calcutta. Then we need to get the Delhi to the Lucknow, and then we need to get the Delhi to the Goa. After that, I need to make a tunnel between this guy to this guy, Patna to Bangalore, right? Patna to Calcutta, right? Patna to Lucknow, and Patna to Goa, right? Then if I'm going to make a VPN tunnel between this, if I'm going to make a GRE between this guy to this guy, we need to make a GRE between Goa to the Lucknow, and then Goa to the Calcutta, right? And Goa to the Bangalore. Can you see how many? And then after that, we need to make a new one between this guy to this guy. Bangalore to Calcutta, right? Between this guy to this guy, and from Calcutta to the Lucknow, right? And after that, not this one, like this. We'll go for the different colors. And then last one, this guy. If you're going to use the GRE, right? What GRE is providing, guys, try to understand. GRE is just going to provide the point-to-point connection, just point to point. Can you see how many tunnels that you have created over there? If I'm going to write on this, so 1, 2, 3, 4, 5, then we have a 6, 7, 8, 9. Then we have a 10, 11, 12, 13, 14, and 15, right? 50 channels you have to create. Can you imagine if you're going to create the 50 tunnels? If you're going to create the 50 tunnels, how many network ID you're going to write over there? Like this one, you have to create the tunnel 1, for example. 15 tunnels you have to create interface tunnel 1. I need to define the IP address for this guy. Then you need to create the another tunnel 2, and channel 3, and channel 15, right? Can you imagine how many networks we are going to use over there? 15 network ID you need to require to create a 15 tunnels. If I'm just going to use the GRE, right? If I'm going to use the GRE, what GRE provide? It's a point-to-point connection, right? And if I'm going to use the GRE in this location, in this topology, I need to have a 15 network that will increase the size of routing table. And forget the size of routing table right now. Forget the size of routing table. Can you imagine how much amount of configuration you have to require? Can you see just for the one site, right? Just for the one site, we need to require this amount of configuration, right? We need to define the tunnel one, then IP addressing, tunnel source, and tunnel destination for this guy as well as. If I'm just going to, if you have a 2 and 3 branch, you can do the GRE, right? You can do the GRE if you just have a 2 and 3 branch. But if you have a multiple branch in this location, is it possible to can you see the how the connection is happening? A full mesh. It's a very bad, right? Maintaining, right? Maintaining the use amount of tunnel, maintaining the use amount of tunnel require huge amount of memory and CPU, and that will degrade the performance of router. If you don't have much CPU, right? First of all, we need to require, right? We need to require this amount of CPU, right? And take example, if you don't have a CPU and memory, that will degrade the performance of the router. It is something like, can we do like this? Sorry. 6 into 6 minus 1 divided by 2, 6 into 5 divided by 2, we can say the 30 divided by 2, we need to make up 15 tunnels. I need to make a full mesh topology, right? I need to make a full mesh topology if I'm just going to use the GRE. And that is totally bad, right? This is not a good design. Your topology is something like this. Patna is going to make a private connection with this Bangalore. Patna is going to make a Calcutta. Patna is going to make a Lucknow and Goa as well as of 50 network ID we need to require. That is going to increase the size of routing table. For I'm not talking about the LAN information. I haven't enabled the MGRP right now. Can you imagine you need to exchange if you're going to make a full mesh topology in this case, the first one network ID will be incremented. You need to require the huge amount of configuration, and for the huge amount of configuration, we need to maintain the complete tunnels. For the complete tunnels maintaining, we need to require the more memory and more CPU. At the same time, after that, I need to exchange my LAN information. To exchange the LAN information, we need to run again routing protocols. Tell me if I'm going to run the routing protocols. If I'm going to run the routing protocols, I need to create a separate, right? Or we can do the same as well as EHRP AS number 1, AS number 1, AS number 1, AS number 1. You're also going to make a lots of configuration for the routing protocols. That is not a good way. That's not a feasible solution. That's not a scalable solution to implement the GRE in this case. To avoid this problem, what we have introduced the concept of problem. Solution is very simple. We have a MGRE. MGRE stand for, it's a multi-point GRE. Multi-point generic routing encapsulation. So GRE is going to provide the point-to-point. GRE is going to provide the point-to-point connectivity, or we can say site-to-site. It's a point-to-point. Whereas MGRE is going to provide the point-to-multi-point. It's a multi-point GRE. I'm going to just change the flavor, right? So MGRE is the overlay tunneling protocol. And by using the MGRE, what happened? By using the MGRE, right? Instead of going to maintain, this amount of tunnels or this amount of network ID, what I'm going to do, I'm just going to convert. It was near like this, right? So if I'm going to use the GRE, I'll make a difference between this guy. And if you have if I'm going to use the GRE between 6 sites, for the 6 sites, what's happened? We need to make a 15 tunnels. If you want to provide the connectivity between all the sites, then you need to create a 15 tunnels over there, right? And for the 15 tunnels, we need to require the 15 network ID. Huge amount of configuration. That require lots of CPU cycle and memory. Whereas by using the MGRE, what I can get over there, I'm just going to reduce this all configuration, right? In just like this. MGRE, like we have a single tunnel. If you have a single tunnel, then we have a single network ID. Doesn't matter how many sites you have. Doesn't matter how many sites you have. For example, if I'm going to use the tunnel network ID 192.168.1.0/24, how many IPs I can use? 254, right? Because 255 is reserved. 255 is reserved for the broadcast. I can use the 254 IPs. So you can make a 254 sites connection. Can you imagine if you just have a 254 sites over there, how many network ID you have to require, how many tunnels you have to require? But in this case, I just need to have a one tunnel, one network ID. This is the benefit that we are getting by making a MGRE. By in MGRE, what happened? I'm just going to make a one tunnel, right? This guy, and this guy has a look like this one, this one, this one, this one, this one. So now the command is like this over there. If you see the GRE command, in the GRE, what happened? I need to define the interface tunnel one. If I'm going to do the GRE configuration like this, tunnel source, I need to define. So where should I perform the encapsulation, right? 0/0, it will get the IP address from the 0/0. And tunnel destination, we are going to define over there like this, right? That make a point to point, that make up whatever the destination you have. This guy is going to make a point to point connection. This person only. I'm just going to change the behavior of this guy. Instead of writing this thing, right? What I'm going to do in the GRE, sorry, MGRE. I'm going to remove this guy and I'm going to change this B because this command is going to make this tunnel as a GRE. I'm going to just change the mode, tunnel mode, GRE multiple. So this command is going to tell this person, hey, you are enabled with the GRE. So basically GRE has a flavor, right? GRE has a flavor that makes a GRE has a two flavor. One is a point to point and one is a point to multi-point. And another is a point to multi-point. The default behavior, right? The default behavior is point to point. This is the default behavior where I'm going to define the destination. Here I'm defining the destination over there. But in MGRE, what happened? I'm not going to define the destination. Here I'm defining the destination. I say that, hey, you have to encapsulate the packet, right? And the termination point, right? The termination point will be 25.2. I say that, hey, you need to perform the encapsulation, but I'm not going to define any termination point. I'm just going to change the behavior. And by making this thing, what happened? By making this thing, I'm just going to change the behavior MGRE. And now I'm going to use the single tunnel or single network ID. Like this configuration happened. Sorry. So it doesn't matter how many sites you have. I just have a single tunnel. And for this single tunnel, we have a single network ID. So can you imagine how many resources of the router and CPU memory I can reduce? How many size of routing table I can reduce over there? Instead of creating the full mesh, right? I'm not going to do the full mesh right now. Full mesh topology always require, always remember one thing. Full mesh topology always require a huge amount of configuration. A full mesh topology always require the huge amount of memory and CPU. I'm not going to do the full mesh. So I'll show you the first configuration of the pre-configuration, whatever that I have right now. So hope I have all the IP addresses configuration on every router, right? And I will have a one default or towards the ISP, right? Because I just need a transport connectivity, right? We must need to have a underlay network to achieve the overlay. So MGRE is the overlay protocol. MGRE is the overlay tunneling protocol. Okay, I need to increase the port size. Happiness change 16 default settings, save it, and router number 2. All good. So if you just have a look the pre-configuration of the router number 1, first of all, right? So IP interface brief. I have a one interface that is a faster than 0/015.1, that this guy, the physical interface, right? And we have one loop back that's behave like a LAN network. I don't have any internal configuration. And if you see the show IP route, I just have a one default route towards the ISP. Okay, if you go back to the router number 2, that's a Bangalore location, right? So IP interface brief. I have a IP addressing configured over there, and I have a loop back show IP route. I have a one static route, right? To just provide the connectivity. That's it, nothing else. Show IP interface brief, show IP route. So if you see the IP addressing on R3 as well as the Calcutta branch, we have a 35.3, we have a one loop back, and we have a default route.
So can you just I can't see the R2, R3 on the diagram. Where okay,
Yeah, this
R3
is
is
the R2,
Calcutta,
right?
is it?
This
What's
is
the
the
R2?
R2.
Okay,
Bangalore,
this is
Calcutta is
R2.
R3.
Oh, okay. So yeah.
So router number 4, we have a show IP interface brief. I'll get 45.4, 4 and 404 show IP route. I have one static router over there. This is the router number 4, right? That this guy Lucknow branch, and we have a last one is a Goa. Show IP interface brief. Show IP route. Everything is cool, right? We have one default router as well as, and we'll go for the router number 7, that is a Patna. Show IP route. One company has a multiple branch, right? You can take a, this is the network home. Network home has a multiple branch, right? The main branch is the Delhi headquarters. As a branch officer, branch 1, branch 2, branch 3, branch 4, and branch 5. This is the headquarter branch. Right? And if you go back to the router number 5, I just need to verify my all configuration on the router number 5, show IP interface brief. That is my ISP. ISP is just having an IP addressing, that's it, nothing else. So if you see, 1 minute. So if you see on 0/0, we have 15.5, 1/0, we have a 25.5, right? This guy, and everyone has a connectivity. Let's do one thing. I'll ping it, ping 255.255.255.255. I will get the reply from every person, right? So this is the best good command, right? To just check the connectivity. So do we have a connectivity or not? So you can use this command in the exam. So you can see, let me do one thing. Let's copy and in the notepad. So we'll do one thing. And if you see, so R5, right? That's my ISP router. R5 will get the reply from R1. So he's getting the reply from the 45.4, R4, R3, R2, R1, right? Is getting from the R6 as well as, and R7 as well as. So I'm getting the reply from 4, 3, 2, 1, 6, and 7. So all we have a proper connectivity. So now also we can check the connectivity from the router number 1. So from the router number 1, I'm just going to ping the all the branch office, right? So branch transport connection WAN interface, right? From here, from Delhi, I'm going to ping from here to here, this guy, a public network, right? Or this guy. So in my topology, I'm using the private network, but actually in the real world, it's a public. So I'm going to use the ping 57.7, all good, 25.2, because transport connection must be there, right? And 35.3, ping 45.4, and the last one we have the Goa is a 65.6, right? The physical interface. So I'm sending the packet through the default order, right? I have just a default order. Based on the default order, I'm sending the packet. All good. We have a good connectivity. So now we good to go for the MGRE. So how do I configure for the MGRE? I just need to come and put the command interface tunnel 1. The same command you can put the long lots of identifier. IP address will be 101. I'm going to use the same network ID on every branch. And tunnel source, I need to define the 0/0 and tunnel mode. Instead of defining the tunnel destination, what I'm going to do, I'm just going to define the tunnel mode, GRE multi-point, just change the behavior. So right now, my interface is still down. If you see, my interface is still down. Do show interface tunnel 1. What I'm going to do, I'm just going to change the behavior. I said, hey, tunnel mode will be GRE multi-point. I'm just going to change the behavior of the GRE. That's it. Once I change the behavior of the GRE, what happened now? It's not going to perform the destination lookup, right? In the routing table, it's not going to perform the destination lookup in the routing table, and it's just going to up this interface, do show IP interface brief, My tunnel is up, and do so interface tunnel 1. Can you see? Now we have a MGRE. Previously it was GRE. If you see, just have a look. GRE. Previously it was GRE, right? Now we have a MGRE. I'm just going to change the behavior. My tunnel protocol transport is the multi-point GRE that works on the IP protocol number 47. Now the same configuration I need to do on a every or do show run interface tunnel 1. I just need to put the same configuration, right? So now router number 1, I did this configuration, right? Exit. Router number 2 also have the same configuration, right? I just need to change the IP address 1 or 2 because they have a same tunnel source 0/0 on this guy as well as. If you have a different source, then you need to change the tunnel IP address or tunnel interface number. 103, 104, R5, so not R5, R6, because R5 is my ISP, right? R6 is the branch office that's Goa, and R7. All they have a same configuration. So can you see everyone has the same network ID is going to use over the 106, 107, same brand or network ID 1.0. So I need to copy this configuration from the R2, right? Copy. Done. R3. Copy. R4. R5. Sorry, R5 is my ISP, so let's remove this guy. I'm not interested. R6. All done. And now we have our router number 7. All done. So all the terminal will be up. Now to show IP route, if you see, I have a routes in my routing table that's a 1.0 connected with the direct tunnel, right? Now try to understand, can I ping this guy if I'm going to ping from R7? Debug IP packet detail. Can I ping 1 or 2? What do you think? Can I ping 1 or 2? This guy is a directly connectivity. If you see, if I'm going to ping 1 or 2, what happened? Encapsulation field. Why? Let me tell you. Let's come back to the GRE point. In a GRE, what happened? If you see, if I'm going to ping from R1, if I'm going to ping from R1, ping 192.168.102, right? That's the tunnel IP address from this side, right? 102 is configured on this side, and 101 is configured on this side, right? So in this case, what happened? Once at the ping 102, the router 1 will create a packet, right? Destination is 102, source is what? 101, this side, right? This tunnel IP address source. So this is the what? It's an inner header, right? What will be the outer header? For the outer header, the source will be 101. One minute, they have seen IP address. I need to complete the other computer. 192.168.1.2. Destination source is 101. Source IP address over there 101. Destination will be outer header, inner header. I have a complete information. I have a complete information.
So destination will be 2.2.2.2, right?
Oh, sorry. Yeah. I have a complete information. This packet will be forwarded. This packet will be forwarded by the router. But right now, if you see, whenever I'm sending a packet from the router number 1, if you see, 1 or 2, router is being dropped the packet. He's continuously dropping the packet, right? Just because of the encapsulation field. Now, to understand this behavior, I'll explain you something else. Let's come back to this point, a very normal language. I'm going to take 2 routers right now. Okay. R8, R9. And I'm going to define the IP addressing on this person will be 101. And I'm going to define the IP address will be 101 or 2. Try to understand this topology right now. A very basic topology. If you understand this one, I will introduce a new protocol over there in the M-GRE. Router 8, router number 9. Sometimes it's slow a little bit. So I'm going to define the interface 0/0 IP address v101.1/8 no shutdown R9 interface 0/0 will be 102 no shutdown. Try to understand R8 MAC address. Do show interface 0/0 include BIA. The MAC address will be C208. And this guy will be R9 hope so it's C209. Do show interface. Yep. 9. All good. Now try to understand if I'm going to ping from R8. Let's say the ping from R8 1.1.1.12. So in this case, what happened? R8 will create a packet, right? In this packet, what happened? The source MAC will be this guy C208. What will be the destination MAC? Source IP will be 101. Destination IP will be 102, right? What will be the destination MAC over there? For the destination MAC, what R8 is going to do? R8 is going to look up the ARP table, right? R8 is going to look up the ARP table. Do we have a ARP information in our R8 table? If you see, do we have information on the R9? Do show ARP? No, I just have a only information. I don't have information about the 101 or 2, right? I'm pinging 101 or 2. I don't have information on 101 or 2. So in this case, what happened? First, I'm going to drop the packet. The first packet will be dropped just because of the encapsulation field. The first packet is dropping just because of the encapsulation field. Can you have a look over there? Because I'm sending this is the ICMP request packet I'm sending, right? Type code will what type will be 8, right? The code ICMP request. This packet will drop just because of the encapsulation field. Because I don't know what's the destination MAC, right? I don't know what's the destination MAC of 102. So if you don't know the destination MAC 102, then what happened? I have introduced the new person. That name is ARP. ARP is what? It's an address resolution protocol that is going to resolve the destination MAC, right, of this particular IP. So what happened at the same time? Once the packet will drop, this ICMP packet will drop, type 8, ICMP request, I'm going to generate the ARP request. Once I will get the ARP entry, now I'm sending the ICMP type 8, that ICMP request, and I will get the reply from my neighbor. Here also encapsulation is dropping, right? My point is very clear to all of you guys. If you don't have a complete layer 2 and layer 3 information, the packet will drop. Same thing is happening in the GRE concept right now. In the GRE, what happened? We have a complete information. We have a tunnel source, we have a tunnel destination 112, we have an outer header tunnel source, and we have an outer header tunnel destination 2.2.2.2. But in this case, when I'm sending a packet from router number 2, where is router number 2? 7. All the packet is dropping encapsulation of field. Why? Because R7 is saying that, hey, let's create a packet. Ping. I want to ping 192.168.102 from router number 7, right? So in this case, what happened? Router 7 is saying that, hey, let's create a packet. Source IP is what? Sorry, destination IP is what? 102, right? Source IP is what? 107. Because once I look up the source IP route information, 102, what this guy is saying that, hey, 102, I have this information 102, and this guy is associated with the tunnel 1, right? So if you want to send any packet for this network, I need to use the tunnel 1. What tunnel 1 is saying that? So interface tunnel 1. Hey, source will be 107. Let's put the source. What will be the source? Source IP this guy, destination IP this guy, outer header, sorry, inner header. What will be the outer? For the outer, what happened? What is the source? 57.7. What will be the destination now? Do we have a destination? No. Encapsulation. This is known as the encapsulation. What's the meaning of encapsulation field message? The encapsulation field message is just going to tell you, hey, we are not able to complete the information. We are missing something, right? When the router is creating this packet, router is missing something, it is not going to find what will be the destination. So in this case, what the packet will drop. But in this case, if you see in the GRE, we are mentioning the destination over there. We already mentioned the destination. That's why the packet is not dropping. But in this case, the packet is dropping. So in ARP case, what happened? We have introduced the protocol that is name is ARP, right? Same thing. What happened in this case? In a MGRE, we are going to introduce the new protocol that is name is a NHRP. What NHRP is going to do? It's ditto behave like a ARP. Only difference is that ARP is going to find the layer 2 MAC address, right? ARP is going to find the layer 2 MAC address. What NHRP is going to find? It's going to find the layer 3 public IP. Because I don't know the public IP. If you see right now, what happened when R7 is creating the packet, in this one, what happened? We have a source IP address, will be 1.7. We have a destination IP address, will be 102 because I'm picking 102. We have a source IP address 57.7, the public IP, but we don't know the public IP of the destination. So we are just going to find the layer 3 public IP of the destination portion, right, by using the NHRP. Ditto behave like an ARP. Only the ARP is going to find the layer 2, whereas the NHRP is going to find the layer 3. NHRP stands for next hop This protocol so resolving can be done in the two ways, like in ARP as well as what happened. In ARP, you can define the ARP entry as a dynamic way or a static way. So right now, the ARP entry that I have learned, if you see, I have learned this entry 1 or 2 as a dynamic way, right? Dynamic has some timer. Same thing in NHRP, what happened? You can learn the destination public IP address in a two ways. Either you can define the static mapping, or either you can define the dynamic. So NHRP is a next hop resolution protocol. This protocol is used to resolve the destination public IP address. You can define the mapping in the two ways. Either you can use the static mapping, either you can use the dynamic mapping. Next hop resolution protocol. By default, NHRP is disabled. Like in ARP, what happened? By default, ARP is enabled, right? By default, ARP is enabled, but by default, NHRP is disabled. We need to enable NHRP on a terminal interface. And how do I enable the first command? First, we need to enable this guy, interface terminal 1. I need to define the IP NHRP network ID. Any number you can take, right? You can take any number from this range. A 4-bit, 32-bit number. You can take any number from this range. So NHRP is the next hop resolution protocol that is used to resolve the destination of public IP, and you can resolve in the static way. You can define the static, or you can use the dynamic way as well as static mapping and dynamic mapping. By default, NHRP is disabled. We need to enable the NHRP on the terminal interface, and you can use IP NHRP network ID. This command is going to IP means what? I'm going to work for the IP protocol. Okay, the NHRP is the next hop resolution protocol, layer 3 protocol, and I need to use the any network ID to enable this guy. And what is the use of network ID? Don't worry, I'll let you know. I'll explain this thing. It's a 32-bit number. You can take any number from this range, but this number is a locally significant. NHRP number, NHRP ID is locally significant. So it means that you can use the any NHRP ID on a router number 1, router number 2. For example, on a router number 1, I can use an NHRP ID 1, 2, 3, 10, 20, 50. Anything you can use from the 32-bit number. This command is just going to enable the NHRP. By default, ARP is enabled. That's why it's sending the ARP request. Can you see that? By default, ARP is enabled, but NHRP is disabled, right? We need to enable this thing. And to enable, we need to use this command. One more thing that I forget. So GRE works, so guys, M-GRE works on the IP v4. It works on IP v6 as well as same time IPX, Internet Packet Exchange. So M-GRE support all those three things, right? IP, IPv4, IPv6, and IPX. So what is the first thing I need to do on this guy, guys? On router number 1, I'm going to use the interface tunnel 1. If you say show IP NHRP right now, just take a command, the verification command. I don't have any information right now. I don't have any information. What I'm going to do, I just need to go in the interface channel 1. I say the IP NHRP network ID, define any ID. I'll go for the ID number 1. Now NHRP is enabled. I can go for the router number 3 as well as the same command. IP NHRP network ID. I can go for the any number. Just go for the 3 now. According to router number 3, I can go for the 3. Right now, I'm just giving you the overview of the NHRP. It's a locally significant number. You can use any number. It's totally up to you guys. But I'll let you know as well as it will create also problem. It's a locally significant, right? But it's recommendation to use. It's recommendation to use the same number. I'll show you that scenario as well as, don't worry. But right now, I'm just going to go through the locally significant, right? But it's recommendation to have a same number. In which case, I'll let you know. Just give me some time. I'll let you know that scenario as well as. But right now, I'm just going to use the different number. You can use the same number as well as. I'm just making all the clear. I'm just clearing all the concept right about the NHRP. And I'm not done with the NHRP. We have more things in the NHRP, right? And on router number 4, I'm going to say interface number 1. I'm just enabling the NHRP protocol on the tunnel interface so that they can understand the NHRP. R5, let me disable the R5. I'm not interested in the R5 because ISP never comes in the picture of VPN. IP NHRP network ID. ISP just going to provide the transport connectivity. And interface channel 1. So 2 protocol I need. One is the M-GRE and second is the NHRP. That's it. To achieve the communication, right? To achieve the communication between all the side, we need a 2 protocol. One is the M-GRE and another is the NHRP. M-GRE is a overlay tunneling protocol. It's a overlay tunneling protocol. NHRP is a mapping protocol. The mapping you can done as a static or dynamic way as well as. But first of all, you need to enable the NHRP on the tunnel interface. So once we have enabled the tunnel, now what we have to do? Can I ping now still? Any person? Go back to the router number 7. Can I ping this guy now? Can you see? Still encapsulation field. Because I just defined the, right? I just defined the NHRP on the tunnel interface. I didn't define the mapping. Should I perform the dynamic mapping or the static mapping? So right now, I'll just go through the static. I say that, hey, router number 7, right? Let's go through the router number 1, or first the Delhi branch. On the router number 1, what I can say that interface tunnel 1, if you want to go to this guy 1.7, use this public IP. Try to understand what I'm saying that, hey, if you're on a R1, I'm saying that, hey, if you're on a ping, to which guy? Use this public IP. This public IP is known as a NBMA address, non-broadcast multi-access. Non-broadcast multi-access. So if you just have a look over there, what I'm trying to say, this person, IP NHRP map, I'm going to provide the static mapping, need to define the NBMA address. I need to say that, hey, if you want to send any packet for the 107, you need to use this person. Private to public. This guy is a private IP. That is the 107 that's belong to the tunnel. And this is the public. That's a transport connection. or also known as a NVMe address, non-broadcast multi-access. Let's do that. What happened? Can you see the one debug message? Sorry, syslog message. NHRP is a protocol, and the NHRP is enabled on which this is the time that what time this NHRP mapping is created. So this is the protocol NHRP, and NHRP is enabled on which interface? Tunnel 1, right? And what we are doing over there, as I told you that we have two types of mapping we can create. Either you can create a dynamic mapping, or either you can create a static mapping as well. As it's totally up to you, right? So right now our focus is static mapping. So once we have created the static mapping for the 107, that's /32, what is the NVMe address for this guy? So do we have any kind of timer over there for static mapping? No. If you just have a look, if I say the IP route, take example 8.0.0.0.255.0.0. Let's go back to the router number 8 right now. I'll show you this thing. All done. Interface loopback number 2. That's a 9 on 9.9.9.9.9 on a router number 8 as well as. I'm just going to show you the static and dynamic difference. Use IP route. Can you see the difference is happening? If you define the static route, do we have any timers? No. But if you define the dynamic routing protocols, we have a timer. Because I learned this dynamic, I put this static. So for the static, we don't have a timer, guys. The same thing is happening. I create a static mapping over there, right? For the static mapping, I don't have any timer. So IP NHRP. It will be never expand. It is just going to tell you what time this tunnel has created, right? I have made the tunnel. I made the tunnel between this guy to this guy. So it's just going to tell you what time this tunnel has created. So this is the 1.7. If you want to send any packet to the 1.7, you need to use this NVMe address. So can I reach to this NVMe address right now? Ping 157.7. Of course I can reach. Of course I can reach, because we have a default route connectivity over there, right? Can you see? Default route. And through the default route, I can reach to this guy. So I say that if you want to reach to this guy, you need to use this person, right? Static mapping. Same thing. I need to do the static mapping for which person? Every person, right? So I did the static mapping on R1 for this guy. IP NHRP network ID 1. IP NHRP map. I'm going to say if you want to send a packet to the 107, you need to use this public IP 57.7. If you want to send any packet to this guy 102, you need to use this public IP. If you want to send any packet to this guy 1.3, that is the 35.3, right? Public IP. If you want to send any packet to this guy 104, who is the 104? This guy, right? You need to use this public IP 45.4. And how do I distribute the 45.4? By using a default route. IP NHRP map 106. That's a Goa branch, right? 65.6. And IP NHRP map. If you reach to the Patna, I need to use this public IP. This amount of mapping you have to create. All this mapping that I did, all are static. And for the static, there is no timer. So can you have a look over there now? If I'm going to copy this command on a router number 1, interface on 1, done. So all the mapping has created. So do show IP NHRP. 1, 2, 3, 4, 6, 7. So 7 was, if you see 7 was already created. So I'm just updating the static mapping, right? Because I already put it this command. Again, I put this command, same information, right? That's why it's in the updating static mapping. But this guy's in the creating, right? Because this is the new one. I already put this command, if you see. So that's why it's updating only. It's not creating. Whenever they put the new one, it's creating. So can I ping now? 107. If you see, if I say the debug IP packet detail, previously the message was coming like what? Previously the message was coming like a encapsulation failed. But now how the message is coming? Now the encapsulation is not filled. Now try to understand how the thing is happening. If I'm ping from R1, 192.168.1.7. So in this case, what happened? The source IP address will be, of course, 1.1, right? Because once I put the destination IP will be 1.7, right? 107 is destination IP. What happened? Router 1 is going to look up the routing table, right? Hey, do we have information of this person? Show IP route 107. He's saying that, hey, I have an information in the routing table and I need to use this interface tunnel 1. So he's saying that show interface tunnel 1. According to the interface tunnel 1, what happened? My source IP address will be 101. So let's put the 101. That's my inner header, right? For the outer header, what happened? Source IP and destination IP. Source, sorry, this is the destination now. So for the outer header, what happened? What will the source IP address over there? The source IP will be 15.1, right? What will be the destination? Destination is still unknown, right? But what happened? The pointing is GRE, sorry, MGRE. When this point is MGRE, when they are going to point to MGRE, what happened? He's going to inform this person, hey, you need to look up for the NHRP cache. Or we can say that in a simple language, we need to look up the NHRP database table. When he is pointing to the MGRE, always you need to focus on the NHRP database table. So according to my database table, if you have a look over there, do we have a mapping for the 107 according to my database table? Show IP NHRP. Yep, according to my mapping information, I have information 107. I need to use this public IP 57.7. So this packet is a complete packet. Encapsulation will be never dropped. So that's why if you see, if I'm sending a packet ping, I'm not getting a encapsulation error message. Can you see? I'm not getting the encapsulation. I'm putting the complete header. Can you see that? I'm going to putting the complete header GRE. How do I get that? I'm sending, right? So this is the packet that has source. Public IP forwarding information base, and I'm sending this packet. ICMP type code 8, that is the ICMP request packet. But problem is what? Once this packet is reaches to this point, right? Once this packet is reached to this point, R7 is creating a reply packet. It is saying the request packet, R7 will create the reply packet. In the reply packet, what happened? They'll put the source IP address what? 107 now. Destination will be what? 101. Inner header. What will be the outer header? For the outer header, he's going to use the 57.7, right? What will be the destination IP over there on R7? Do we have a mapping for the R7? If you see, when this packet is coming to the R7, what R7 is doing? Why? He said that, hey, show interface channel 1. I don't know what should be the destination, but my pointing is what? MGRE. If this guy is pointing to the MGRE, I need to look up for what? NHRP cache. So do we have an information in the NHRP cache for the 15.1? No. I don't have a mapping information, man. The packet will be dropped just because of the encapsulation field. So I need to do the same mapping on every single router. I need to do the same mapping on this guy, router number 2. On a router number 2, I just need to change this behavior with the 101, right? On a router number 2, I need to put the mapping for the R7, R3, R4, R6, and R1. Router number 3, first of all, I need to network ID is already given, right? I need to put the mapping for this guy. So 103 will be now 101. On R3 mapping is correct, right? R3 has a mapping with the R2, R3 has a mapping with the R4, R3 has a mapping with the R6, R7, and R1. Same thing we need to do on a R4. So right now, I'm just going to use the network ID as a locally significant, right? But it has to be recommendation same. The recommendation is use the same. Why? I'll let you know. All good. R5, R6 now. And now we have R7. All good. So I need to put the same configuration on the R7. Let's start from the R7 now. So here I need to put the mapping, copy R7. Come on. Done. So now we got the mapping, right? Same mapping I need to do on the R6. Same need to do the mapping for the R4. Okay, I have extra mapping on this guy, right? This should be not an extra mapping on every row. Yeah, it's correct. So R4, R3, extra mapping is this type. And now last R2. So it has to be a IP NHRP network ID configuration like this. Copy R2. All done. R8, I'm not interested right now. Let's remove this guy. R9 is not interested. So everyone has a complete mapping. You see any of the router show NHRP. So every information will be stored in the NHRP database table. Okay. Why they not have?
In this, you didn't mention the network ID, sir.
Oh, yeah. So see, can you see that what happened if I'm not going to mention the network ID, NHRP will be not enabled, right? And if the NHRP will be not enabled, I can't do anything. Show IP NHRP. Also good troubleshooting, right? If you're not going to enable the NHRP, your mapping will be not there. So every mapping has a static bit. So tell me where you want to ping. I want to ping the 102, sorry, 101. I want to ping the 107. I want to ping the all the tunnel IP address I can ping 103. I want to ping 104. I want to ping 105. That's it. All branch I can ping. 106 is remaining. All the branch office I can ping now. What is the next thing is happening over there, guys? Need to run the routing protocol, right? Need to run the routing protocol to exchange my routes. That's the most important, right? LAN to LAN communications. All the branch office, right? How do I do that? I need to enable the HRP, right? So let's go to router number 1. Start from the router number 6, right? So router number 1. Router HRP number 1 network 1.0.0, right? Copy, exit. This configuration has to be pasted on every router. Router number 2, 3, every router you have to put the configuration. Router agent. I need to enable my tunnel interface, right?
Don't you have to advertise that LAN loopback IP is?
I'm coming to that point as well as 1 minute.
Okay.
So let's enable the HGRP, right? If you go on a router number 1, let's capture this link first of all. Go to router number 1. Router number 3, 4, 6, 7, and 2. What happened? Again, problem. EHRP works on the 88, right? Encapsulation field. Are you able to see any kind of a hello packet over there? No, I'm not able to see any kind of hello packet, right? All the packet is dropping encapsulation field. Hey guys, just give me 2 minutes, right? I'm just going. Hey guys, the problem is very simple. If you just have a look over there, any router, show IP and HRP, what mapping I have. The common thing, right? The common thing about this all mapping, if you just have a look, all this mapping is a unicast. So unicast is good, right? What about the multicast mapping? Do you have a multicast mapping? No, I don't have any multicast mapping over there. Do we have any mapping for the .10? Because EHRP is will send a EHRP hello packet on .10, right? 224.0.0.10. I don't have mapping for the .10. Then how we can form the neighborship? All the packet will drop encapsulation field is there, right? What I can do over there, interface channel 1, IP and HRP map multicast. What I'm going to tell this person? What will be the NVMe address right now? I'll do one thing. I'll put the command in the. This is for the unicast mapping. Come on. Now, IP and HRP network ID, same tunnel interface, right? Sorry, IP and HRP map multicast. Or say that, hey, 57.7 IP and HRP map multicast 25.2 35.3 45.4 and 67.6. Maybe this is right. 65.6. Done. Same mapping I need to do on which person? On every router, right? Router number 2. Unicast mapping has done multicast mapping. it has to be 15.1, right? Router number 3, it has to be 15.1, this guy. It has to be 15.1, 6, 15.1, and router number 7, 15.1. I don't have this mapping. No, on every router, we need to provide this amount of mapping, right? So let's go start from the router number 1, multicast mapping, copy. Done. Same thing on router number 2, right? One minute. Before we disable the debug over there. My mistake is happened, right? Come on, I need to shut down this router. One minute. You're good. Reconnect again. Meanwhile, I'll do one thing. I'll provide the mapping on our remaining routers, right? So router number 2, I need to do the mapping for this person, right? Copy. Okay, interface channel 1, same mapping on this guy. On router number 3, I do the same mapping, right? Multicast mapping. Interface channel 1, do the multicast mapping as well as router number 4, the multicast mapping for the R4 as well as interface channel 1. All good. The router number 6 now, that's a Goa branch. All multicast mapping done on R6, and now last R7. And why do we need a multicast mapping, guys? To just make a EHGRP neighbor relationship, because the R7 also have a lots of things. I need to move this up.
So once we do the multicast mapping, can we remove the static mapping?
Multicast mapping I'm doing for the EHGRP. Static mapping I'm doing for the internal IP addressing. Multicast mapping I'm doing for the to enable the EHGRP on the overlay network, right? So that we can exchange the route after enabling the EHGRP.
Correct, but with the multicast mapping, we can still reach the tunnel IPs, right?
How do I reach to the tunnel IP? Tell me how. Can I do the unicast communication over there? Tunnel IP.
I mean, like for instance, R7 will be a part of a multicast group, which R1 is also. So
I'll
that
show
way
you
we
that
can.
thing as well. It will not possible. I'll show you that thing. No worry. I'll show you.
Okay.
No worry. So now R7, I need to put the again full configurations. So I'll do one thing. From here to here, I'm going to and copy and interface turn on. All done. So all good on R7, right? On R1 as well as on R1 also I need to do the full configuration, right? So from here, user mod configuration. Copy. Multicast mapping done. NHRP inversion. So now if you just have a look, guys. Now if you just have a look, show IP NHRP. I have a unicast mapping at the same time. Show IP multicast. Not show IP. Show IP NHRP multicast. I have a multicast mapping. And every mapping is a unicast, static way. Unicast mapping. This is the unicast mapping, that's a static bay, right? At the same time, I did the multicast mapping for the static bay. So this mapping, I just provide I just make a reachability of tunnel IP. This I'm going to do to make a reachability, not to make a reachability, we can say right now, to form an EHGRP membership. So why do we need of EHGRP membership? To exchange my LAN information. So now, if you have a look on R1, I have a 5 membership. So IP EHGRP neighbor. Can you see that? 5 membership. What is the next thing I need to do? I need to advertise my LAN information, right? So on router number 1, I need to advertise my router EHGRP number 1, network 1.0.0.0. Router number 3, all LAN information. Router number 2, 4. Router number 6. Router number 7. Router number 2. All done? Yep. So now if you see on a router number 1, I'm able to receive all the routing information. Can we have a look now? Every single information I have. So how my topology look like this right now? If you just have a look, my topology is something like this. I'll draw it over there. So how do I achieve the overlay network? My overlay is something like this. So this is an underlay. Overlay will be R1, right? R7, R2, R3, R4, R6. And they have a connectivity like this. Sorry. Oh, sorry. This is my overlay design. So they have a direct connectivity. Can you imagine the ISP never comes in the picture now? Doesn't matter how many routers are there in the ISP network. It doesn't matter. Just have a direct connectivity. So if you just have a look on a router number 1, I have a 5 membership, right? Router number 2, sorry, 3. So IP route. Router 4. So IP AGRP neighbor. 6. So IP AGRP neighbor. All good to go. Router number 7, the Patna. So IP AGRP neighbor. Router number 2. So IP AGRP neighbor. tell me which one of ping. I want to ping from R2. I want to ping the 2.2.2.2. Sorry, 1.1.1. The Delhi. From Bangalore to Delhi, I'm pinging. I can ping. From Bangalore to Calcutta. From Bangalore to Patna. From Bangalore to Lucknow. From Bangalore to Goa. I can reach all the sites over there. I can send my all the traffic from all sides from here, right? I'm posing on here. I can send my all the sites to site connection over there. This guy, this guy, this guy, this guy. So I'll make a more difference over there. I'll do one thing. I'll take a screenshot of this guy, not this one. I'll make a difference now. Okay. This guy, Delhi branch, all we have. And so now we have a connectivity like this. So in a GRE, we need, if you want to provide the communication between all the 6 sites, I need to have a 15 terminals, right? 15 for the 15 network ID, right? Network ID, and this is the routing table I'm talking about, right? And this 6 sites, if I'm going to do this configuration of 6 sites, what happened? We need to require the huge amount of CPU and memory resources, right? So now we have a connectivity like this. I can make R1 has looked like this connectivity. R1 has looked like this in GRE perspective, right? This guy, and this guy, right? So like R1 has connected. If I'm going to talk about this person now, R7 to this guy, R7 to this guy, R7 to this guy, and R7 to this guy, right? If I'm going to talk about this guy, black one I can take from R2 to this guy, from R2 to R3, sorry, R4, and from R2 to R6. Again now, blue one I can take from here to here. 15 tunnels. This GRE. And if you talk about the M-GRE, now can you have a look at the M-GRE? How the M-GRE will look like this? This is my M-GRE. You can see it. Single tunnel. 6 sites, same site, 6 site, 1 network ID, 1 time. Main difference. Let me know, guys, if you have any questions. This is the difference between GRE and M-GRE. This is the M-GRE. It's an overlay tunneling protocol. It's an overlay tunneling protocol that provides the point-to-multipoint connection. It works on the IPv4, IPv6, or IPX as well as.
Now, one small query, like MGRE for overlay, we used EHRP, right? When we implemented EHRP,
Right.
overlay we implemented EHRP. For underlay, static routes was there, right?
To just provide the transport connectivity, that's it.
Okay.
You can underlay you can use the OSPF as well as you can use the BGP as well as it's totally up to you. I just need to have a utility of underlay.
So for overlay and underlay, both we need to have separate connectivity, like separate protocol.
Of course, we have a two topology, right? So can you see that we have a one we have this topology and one we have this topology. Two topologies. Topology 1, this is the underlay, and this is the overlay. Underlay, overlay. So for the underlay, we need to have a utility. For overlay, we also need to have a utility, right? Two protocols I need.
Suppose if we use OSPF for both with different process, it will work.
I'll explain you. I have a one very good topic. I cannot say the topic of that, right? Okay, I'm asking you a quick question to all of you. What do you think? Is overlay is good? Is overlay good? According to you?
Yes, it's a good.
Right? It's a good, right? According to you, it's good, right? I will give you the two problems of the overlay. After the batch, not now. Once we have done with the DMVPN part, right? Then I will give you the problems of the overlay. See, I'm not denying it. It's bad. It's good, but even overlay have some issues. Not the perspective of like packet forwarding and something like that. They have some issues, right? I'll let you know that issue. Don't worry. So this is the MGRE and GRE, guys. Now you can ask me a question. I forget to. Yeah, Parun, any question to you?
Okay.
So
Yeah.
go ahead, please.
NHRP, basically the encapsulation is failing because we are not getting the remote public IP address.
Yeah, because we don't have the mapping of that.
Suppose, is there anything we can do the Mac based mapping?
How Mac is a, if you remember one thing, in Mac is a layer to right. It's not travel on the high speed side. It's
Oh,
the
yes.
same.
Okay, thank you.
Okay, my question was, yeah, so since we configured EIGRP, sir, on the tunnel interfaces, and we configured multicast mapping on there, right? So I was wondering, if you remove that particular static mapping,
Let's remove it. Yeah, this question.
What will happen? Yeah.
Yeah, let's remove it. That's it.
Because at the end, your source and destinations are still reachable, right?
Don't worry. I'll just no interface.
No, not no interface. Sir.
Because I need to remove the whole mapping, right? So I'll just no interface. I'll just copy this.
Oh, okay.
I'll do one thing. So they will break the membership, and now I'm going to do this configuration network ID and multicast mapping information. Oh, shit, man.
I think you copied R1.
R2. R2 this guy, multicast mapping. Sound good? Show IP, HGRP neighbor. Show IP, NHRP. No. Can you see the mapping is incomplete now? Can I ping this guy in eternal? I can't. Yeah, Swami.
Well, I didn't understand why it is not able to pick that
Why?
information.
How they will pick? Just tell me. Okay, let's create a packet. Then you will understand this thing. From R2, I'm pinging home. From R2, I'm pinging
R1.
Okay. So in this case, what the source IP will be? 1 or 2, right?
Correct.
Destination will be what? 101, because I'm pinging 101. What will be the source public IP? Source public IP will be 25.2, right?
Correct.
What will be the destination public IP?
Destination would be your multicast, right?
Oh, how's the multicast? I'm pinging 101, right? I'm not sending you multicast stuff.
Okay. Yeah.
So for the destination multicast mapping, I need to look up the NHRP table, right? Right now?
Yes.
So in NHRP, do we have a mapping of the unicast? Can you see? The flag is incomplete. 1 or 2, 101, right? For 101, what happened? The type is incomplete, means what? We don't have a NVMe address. Do we have an NVMe address over there? No, right? Okay. I don't have an NVMe. How can you send traffic? I did the multicast, so that's why they are forming the EIGRP membership. They are just resetting the EIGRP membership, right? because no, they know how to follow. If you see the show IP multicast, show IP, NHRP multicast, they know how to follow the multicast mapping, right? Because they all have a mapping for the multicasting. But what about the unicast? Do we have a mapping for the unicasting? No, I don't know what's the NVMe address. How do I reach to the NVMe? The encapsulation fail will be happen, right?
We are doing because multi-GRE is point to point or point to multi-point. So just to make it
We need to provide the
uh,
mapping, right? We are not, see, Swami, we are not doing point to point. We are doing point to multi-point. We are not defining the destination. For the destination, we need to resolve from the NHRP, right? We need to define the static mapping. Okay. We are getting the problem debug IP packet detail. The debug. Okay. See what happened.
Okay.
It's clear now. I'm
Yeah,
sending the
but
packet to source 101, destination 102, 101. I don't know where should I forward the packet. The encapsulation failed because it's look up the NHRP table. NHRP is nothing, information is there, right? Clear now?
yeah.
Any question else? Anyone?
So that's the complete MGRE config, right?
Yep.
So then when you get into the dynamic mappings, now you're into
Yeah,
the
we need to go for the
VPN
dynamic mapping. That's a
curriculum.
DMVPN.
Okay.
This is the MGRE. Right now in the market, guys, we are not using the GRE. So it's not like we are not using the GRE. It's MGRE we are not using. GRE we can use if you have a 2 and 3 site, you can use the GRE, but MGRE is not using. MGRE has a lots of configuration, right? We'll solve this configuration by tomorrow in DMVPN part. All good?
So,
Okay, guys. Yeah.
Means there should be the drawback of the
Yeah,
MGR.
we have a
That
lots of
drawback I
drawback.
want to know.
Can you see? Can you see the huge amount of configuration?
That's it, nothing else.
Nothing. Not this. The first of all, this amount of configuration you have to do, right? And second
Yes.
thing, what? If I'm going to bring the new sites over there, if
Uh,
I'm going to bring the new sites over there, what happened in this case? You need to provide the mapping on the R7, R2, R3, R4, R5, even R1. So you have to do the configuration on this new router. At the same time, you have to involve every router. Hey, please do the configuration. So there is no dynamic approach. All the static approach is happening, right? As I told you that this is the static mapping we are doing over there right now.
okay.
We'll
So
go for the
only
dynamic. Dynamic is very easy, right?
okay. Okay, got it.
Let's see this. MGRE, LMMC. All good, guys. Hope this thing is clear to all of you. If you have any questions, you can ask me. I'm done.
It's a nice one.
Thanks. No? Okay, guys. Then see you. Bye-bye tomorrow.